Professor Yang was the chair of the first summer school on fog/edge computing, which was held at ShanghaiTech. So this is the second winter school that we are doing. So Professor Yang is the one who started off the summer school on fog/edge computing at ShanghaiTech. So it's great to have him talk at this event. So I'll give a brief introduction to Professor Yang. So Professor Yang is currently a full professor with the School of Information Science and Technology, Shanghai Tech University, China, as well as the Master of Kedauf College and the Director of the Shanghai Institute of Fog Computing Technology, which is in short called as SHIFT. Yang's current research interests include fog and edge computing, 5G, IoT, and wireless testbeds. He has published more than 260 papers and filed over 80 technical patents in these research areas. Yang is also a fellow of the IEEE. So, Professor Yang, we're happy to have you here. I invite you to start your talk. So, Professor Yang, are you able to hear us? Professor Yang, we are not able to see you. Are you able to hear us? Professor Yang, we are not able to hear you. Jana, are you online?
Yes, sir.
Can you turn on your camera?
Yes, sir.
Okay, I think then the problem is from Professor Yang's side, right? Is that correct?
Yes, sir. He may be, he have to restart, I think. Because his microphone shows that he is telling something. There is some levels changing, but
Professor Yang, we can't hear you.
He's typing in the chat box.
Yeah, but you, yes, we can't hear him, no? We can't hear you. What should we ask him to rejoin? Professor Yang, I think if you can rejoin, because we have a dark screen and we can't hear you. Okay, if you can send us the pre-recorded video. No, we don't. Yang, we had a problem with the pre. Do we have the pre-recorded video, Gana? Dark screen and we can't hear you. Okay, if you can send us the pre-recorded video. No, we don't. Yang, we had a problem with the pre. Do we have the pre-recorded video, Gana? Dark screen and we can't hear you.
sir, we can play a recorded video.
But do you have the video?
No, sir. We have not sent.
Okay, if you can send us the pre-recorded video. What is this playing in the background?
Sir, it may be the YouTube live, sir.
No, but we have a problem with Yang's video and audio, right?
Yes, sir.
So let's wait. I think he's trying to rejoin.
I sent a video today.
Do you have a video?
Sir, once I'll check, sir. On mail. Speakers.
Professor Yang, can you hear us? Gana, can you see the panelist, sorry, the attendee, this one, and check with one of the attendees to type in whether they can hear us, just to double check.
One. Yes, sir, the attendees can hear us.
Okay, they're confirming me.
Yes, sir, in the chat also they confirm.
Okay, can you check with the attendees once again whether can you hear? Yeah. So Yang, the problem is from your side. All the attendees can hear us, and see us, but they can't see and hear you. So Yang, if you can send us the video, probably we can try and play that. Gana, there was an email from him, right?
Yes, sir.
Can you just check that?
Yes, sir, I'm checking the email. No, sir, till now we don't have any mail.
Just a minute.
Rajesh, there is an option of connecting from phone also, I guess, for audio. Maybe we can try that.
Yeah, I think we can see him now. Yang, we can see you now.
Okay.
Yeah, we can hear you now. Yes, yes.
Okay. So what happened?
Yeah,
Okay.
I don't know. It's very strange. It's the first time it happened over 2 days.
Okay. Yes. So do you have the video, or if not?
No, we
will...
don't have the video, Yang. You can just go ahead and give us a brief. This one, even you can be brief. No
okay. Okay. So I will share my side. I just broadcast that video, so it's easier.
Sure. You can do that. You can do that. Yeah.
Okay. Thank you. Just a minute.
Sure. Yeah, yeah.
It was showing that Dr. Ang's network is poor. Maybe that was a problem.
No, no problem. But he's online now. He can. Yes, we can see your screen now. So, Yang, I think we have a problem with the video. I think it is playing at your end, but not playing here. We can see only your screen.
You cannot see the video, right?
No, no, we can see you and hear you and your screen, but not the video.
Okay, so I will present from my side.
Yeah, Yang, you can give us a short overview since we have lost time. It doesn't matter. I mean, a few, a short overview should be fine. So if you can share your screen with the slides. Okay, Anna, I think we have lost him again, right?
Yes, sir. I think so because again there may be some network issues.
Yeah, I think he has some issues from his end probably.
Yes, sir.
Yes, sir. It was displaying his bandwidth was low some time ago.
Yeah, we had the next speaker, but I don't think he's there online now.
Let me check.
We had him for some time. I think he's not there now.
Jack Chen. No, sir.
Yeah, I think Zach, are you able to hear us?
Hello.
Zach, you can hear us?
Yes, yes, I can hear.
Can you turn on your video?
Yes. Wait a second.
Yeah, hi Zach. Actually, we are having trouble with Yang connecting. This is the first time we are having trouble connecting Yang. So we are just waiting for him to connect. So your talk is after Yang's talk.
Okay.
So Yang, are you able to hear us?
Sir, can we swap the talks?
No, we can actually, if Yang is okay, we can start with Zach's talk and then probably see what to do next. So Yang's talk is at 2. It's already 1. So we have just 10 minutes to his talk. So Yang, you are able to hear us? I think, shall I ask Yang if we can start with Zach's talk? So Yang, can we start with Zach's talk and then maybe see if your network is fine, start your talk after Zach's talk?
No problem. Okay.
Okay, Yang, it's really, I mean, we would have loved to hear you talk.
Okay, no problem. Yeah, I'm actually staying university, so I think the network is quite stable here. But yeah, something.
So Yang, can you? I mean, you can probably go ahead and give us an overview for 5 minutes. It doesn't matter. You can go be on audio and give us. I mean, give the audience, you know, a brief overview of what you wanted to speak.
Okay, so you can hear me now, right?
Yeah, yeah. We can get your audio right. Yeah.
Okay, so I will make this very quick. Okay, this one. Can you see my slides?
We can see. Yes, now we can see you. Yeah, yeah.
Okay,
Yes,
so
yes,
yeah,
yes.
thank you very much, everyone. So it's a little bit trouble at the end of 2020. So we have many troubles in this year. So my talk, I will skip the background because everyone knows what is fog and why we move the computing resource to the end of the network, because we have a lot of IoT sensors which generate a lot of data. So we need to handle those data from the edge to the cloud along the continuum of this cloud to things. So we propose this structure to be changed from the previous cloud channel and edge structure to this fog-enabled new network structure that will enable a lot of computing resource inside the network to support data processing and the information analysis during the transmission process. So we are considering a key problem like this. Just like in any company or university, you have a hierarchy of management. You will not give all the orders to the CEOs, or you do not put all the duties to the customers or frontier managers. So you need to managers along the line between the customer to the CEOs. So Fog does exactly the same thing. They want to make the whole network smarter. So the key problem here we want to deal with is to handle the task. You want to deliver a task to a neighborhood, which can help you. So the cost is the communication cost, and you gain some computing resources. Just like if I want to assign a job to my student, I need to communicate with him or her, and then he or she will do the job for me. So that's exactly the same case in the fog computing network structure. You need to distribute those tasks among different nodes. So depends on the depends on the task if it could be splitable or not splitable. We divide the task into two types, and in order to handle both type of tasks, we have two different scheduling schemes. But both schemes considering the delay constraints and energy constraints. So you have different mechanism to calculate the total delay for distribute this task, and also you have the mechanism to calculate the total energy consumption and the cost in doing this. So we have two schemes, but the key question we want to answer is how to design a distributed task scheduling algorithms for heterogeneous fog edge networks with multiple task nodes and multiple helper nodes. It's just like we are in our community, we want to help each other. So the structure is looks like this. So suppose you are the task node TN, and you have a task to finish, and then you find someone in your neighborhood they are kind of idle or they are willing to help. So here, the helper node are in white and the busy nodes are in black. So you want to send your task to the helper node, so the helper node can save your time and do the job for you. So that's exactly the situation in our daily life. Okay, but here we are considering non-splitable task, which means you either do the job yourself or you ask someone to do the job for you. So that's a binary assignment of tasks. And then you develop a model to analyze this problem. It consists of the communication cost because you need to send this task to a neighborhood. So that's the communication delay or communication cost. And then you also have this computing capability of your neighborhood. So how fast he can do the job for you. Okay, so you have this analytical model to formulate this problem. The key question is to minimize the total delay by assigning a task to a neighbor. Okay, I skipped the formulation and analysis part because of the time. And if you are interested, you can go to the papers to see the detail. This is the key takeaway. Here, this red line is very close to this blue line, which is the optimal solution. So our distributed prompt algorithm can approach this optimal centralized scheme very well. But the key answer or the message you want to take away is this yellow one. Yellow one, the yellow curve represents you always upload the task to the highest data rate node, which means just like in your life, if you are always say yes, you are the yes man. So your boss will always assign tasks to you. So so that means you assign the task to someone who is always easier to persuade. So you can see here, the yellow line will go busted very quickly because it will beyond its capability. So that's the key message you can take away, and you say to your boss, I cannot say yes to all your requests. I need to reject some of your requests. This purple one, the purple curve is a random assignment scheme, which means you always assign the task to the first node in your neighborhood. So somehow you distribute your task to different helpers. So that's a healthy system in the long term. So that's the performance one. And also in terms of the number of beneficial task node, you can see this distributed approach actually achieve very good performance comparing to other random or highest data rate approach as well. The second scheme is to split tasks into subtasks. So just like if you have a very challenging task, you cannot find any friend to help you with the whole task. So you will distribute this task, divide this task into smaller pieces and ask 3 or 4 friends of you to do the job for you. It's just like in my university, I will always assign several PhD students with the same challenging task. They will do a piece of the subtask and then they'll complete almost at the same time. We can have a very good consolidated solution. So this is we call it a splitable task scheduling. So I skip the algorithms analysis and then we go to the results. So the results show you, comparing to the previous solution, the blue one, actually the post algorithm give you better results because you actually maximize the capability of your neighborhood. You actually invite more helper nodes to help you. So you can further save the delay in your system. So that's the reason we want to split the task among several nodes to do the same job. And then this is a comparison between the previous one, the blue curve, and the new one. So you can see we can further reduce the system delay by dividing the task into smaller pieces. And in terms of a number of beneficial nodes, you can also have a huge jump simply by dividing the tasks into smaller pieces so that more helper nodes can effectively support you at the same time. In terms of complexity and convergence, you can see the proposed distributed algorithm has a tool for the simplicity comparing to the centralized optimal solution. So these are the two papers, including all the details. Basically, we model this scheduling problem as a multitask, multi-helper problem. And according to two different types of tasks, we have splitable scheduling scheme and also the non-splitable task scheduling scheme. We model them as potential games, and then we come up with the right solution. So I stop here. Just in case you have any questions, please ask me in the chat box. Thank you very much.
Thank you, Yang. And we would have loved to hear you speak, but then we had this issue. But then it was an interesting talk. We would have actually loved to hear you more.
Okay.
But,
we always
but in
have
any case, it was great to have you speak, Yang. By the way, just for the information of the audience, Yang was the chair of the first summer school. They had a very successful first summer school on fog and edge computing in ShanghaiTech. So we are happy to have you here, but unfortunately we had a very short talk. But Yang, thanks a lot. We hope to continue working with you.
Thank you. Yeah, enjoy the winter school. Thank you, Chair.
Sure, Yang. Thanks.